So it's very common in lab to make up a stock solution that's concentrated that is then diluted to use in experiments. So calculating the dilution of solutions is important in chemistry lab. What we find is this is the equation. The concentration initially times the volume initially will be equal to the final concentration times the final volume. So let's look at some of these problems. What is the final concentration? So we don't know the final concentration. C2 is unknown. When half a liter of 6 molar hydrochloric acid solution is diluted to a final volume of 1 liter. So the final volume is 1 liter. And the initial volume is right here. So we've got an initial volume, the starting one, of 0.5, and we have an initial concentration of 6 molar. We need to make sure we put units on all these. Okay, so this is our equation. C1 V1 is equal to C2 V2. And we have everything except for C2. So I want to solve this equation for C2. C2 is going to be equal to C1 V1 divided by V2. If you don't believe me, get out your algebra textbook and practice. Okay, and then we can just fill in. We didn't put 1 there, but the concentration 1 was 6 molar. The volume 1 was half a liter, sorry. And the final volume is 1 liter. Okay, it's very important you make sure that your units are going to cancel here. We've done liters and liters, so those cancel. And we end up with 3 molar. And this is a hydrochloric acid solution. Okay. So we can do this using measuring concentration in moles, or we can do it using the concentration measured as a mass volume percent. So what volume? So we don't know the volume. Of a 2% mass per volume solution, so this is going to be our concentration, can be prepared, so that's the 2, by diluting 25 milliliters. Our initial volume is going to be 25 milliliters of a 14% stock solution of hydrochloric acid. Okay, so we can do this problem the same way. C1, V1, C2, V2. This time we don't know V2, so V2 is going to be equal to C1 V1 over C2. And so concentration 1 was 14%, so we'll put that in. Volume 1 is 25 milliliters. Concentration 2 is 2%. Now, last time I used liters, and this time I'm using milliliters. And it will not matter as long as I am consistent with my units. Okay, so the answer here is 175, and because this is milliliters, this will be milliliters. The percents here cancel out, and that leaves us with milliliters, and that's what we find in our answer. What is the molarity of a solution prepared by diluting 0.18 liters of a 0.6 molar nitric acid solution to 1.54 liters. So we don't know the molarity. We're looking for molarity is concentration. So we're looking for concentration, and we don't know that. We're diluting this stock solution, and the stock solution we're told is 0.600 molar, and we're going to use 0.180 liters. The final volume is going to be 0.54 liters. So this one's a little bit confused because we've got, this is what we're diluting. So that's our initial, and this is our final. C2 is going to be equal to C1 V1 divided by V2, and then we can just fill in. Initial concentration is 0.600. And with all of these, units will not matter as long as you're consistent so that they will cancel. And this time we've used liters, but it's okay because we're going to divide by liters. So our liters are going to go away, and we're going to be left with molarity. Back to this color. And our answer here is 0.200.